This is lesson 87 in Saxon's Algebra 1 3rd edition. And this lesson is on two different things. One is a little bit more on solving systems of equations, and then secondly on how to test on a graph for a function. So when we solve systems of equations using the substitution method, not elimination, sometimes we have to rearrange one of the equations before we can have something to substitute in. And this is a perfect example. Here we have TE plus TW equals 9, but we don't have anything for really either one of them separately. So if we take TW and subtract it from both sides, then we have something here that we can substitute in for the TE. So TE now equals 9 minus TW, and that's what you can substitute in. Okay, so here's an example. This is what we're given, and we're told to find T1 and T2. But the only thing we know the R1 and R2. We can go ahead and substitute those in. But the only thing we know here is that the two of them together equal 10. So if we do the same thing I just said, we subtract 1 and put it on the other side, then now we have T1 equals 10 minus T2. And now we can substitute this in, as I've done right here, in the place of T1. Okay, so then after you've got that, the rest is just working it out like you have been doing in the past with your substitution method. And once you find what T1 is, or T2 here, we find is 6. Well, if T2 plus T1 is 10, and this is 6, then this has to be 4. So hopefully this is just a very small element that's been added onto your substitution problems. Okay, now let's get to the vertical line test for functions. And this says that a set of points like this or this in a coordinate plane is the graph of y as a function of x if and only if no vertical line intersects the graph at more than one point. Alright, so here you can see on this graph, when you draw a vertical, it has to be a vertical line, it's going to intersect this graph on here and here in two spots. So this cannot be a function. However, this, when you draw any vertical line, if I were to draw a vertical line here or here, it's only going to intersect this graph at one point. So this is. So A is not a function, and B, yes, is a function. And here are some examples. This is just like the one I just showed you. You draw this vertical line, and it's going to touch two places. Okay, even way back here, it's going to touch in two places. Here, if you draw a vertical line here, it's going to touch in two places. On this one, it's only going to touch in one place. But on this one, this curved shape like this is called a parabola, and parabolas are not functions. Okay, so that cannot be a function. Okay, so for our practice problems, we have one practice problem, or no, I think we have two, with systems of equations. So let's get down to that. I've worked it out here for you. Let's talk through it. We know that R1 plus R1T1 equals R2T2. And then we know T1 plus T2 total is 60. We know that R1 is 3 and R2 is 6. Okay, so we're going to subtract T2 from both sides so that we'll have something to substitute here in the place of T1. T1 is now equal to 60 minus T2. I substitute everything in that I know, and then I begin to solve. I distribute here. 3 times 60 is 180. 3 times negative T2 is negative 3 T2 equals 6 T2. Now I'm going to cancel out this T2 here. I'm going to move it, so I have to add to get rid of it here. So I'll add it on both sides. When I do, I have 180 equals 9 T2. And then when I divide both sides by 9, I'm going to find out that T2 is equal to 20. Now I come back over here, and I know that between the two, they're going to equal 60. So if T2 is 20, then what plus 20 is 60? It's 40. This is another one just like it. ROTO equals RSTS plus 16. Okay, so this is different, but what we're going to have to do is not really any different. We're still going to have to get, we know TO, we know TS, but here we're going to have to get something that we can substitute in either one of these places. So we're going to subtract RS from both sides, and now we have a value for RO that we can substitute in right here. And now we know that RO is equal to negative 1 minus RS. We substitute that in. We put the 8 in that we know. We put the 4 in here for TS that we know. And then we do the math. Alright, so here we have negative 8 minus 8RS equals 4RS plus 16. Now, I'm going to try to move my 8RS over to this side and then my number over to this side. So I add 8RS on both sides. When I do, I get 12RS. And then I'm going to subtract 16 from both sides. And when I do, I get negative 24. So negative 24 equals 12RS. When I divide by 12 here to get RS alone, I divide by 12 here, and I find out that RS is negative 2. I put it in. I then substitute it in to this original equation. RO equals negative 1 minus, and then I put it in parentheses, negative 2, because this is going to change this sign. So RO is negative 1 plus 2, therefore RO equals 1. Alright, and then these are C, D, and E come from your book. I simply took a picture of it. And we're going to draw a vertical line, and we're going to see if each one of those is a function or not. Okay, if I draw a vertical line here, it touches right here at this point. If I draw one here, it's going to touch here, here, it's going to touch here. So it's only going to touch in one spot. So this C is the graph of a function. Alright, now when I draw my vertical line here, or here, or here, I can see that it's going to touch my figure in two places. So this is not a function. Remember, I said this is called a parabola. A parabola is not ever going to be a function. Alright, and then E, draw my vertical line anywhere I want on to touch this, and I see that it's only going to touch that line in one place. So E is the graph of a function. Alright, good job, good luck, and I'll see you next time for lesson 88.